All right, I'm going to be talking to you guys about how to graph real and non-real solutions. And I'm not talking about graphing specifically, I'm just talking about sketching a graph here. So I don't really care even where it crosses the X or the Y. I'm just trying to figure out when I'm looking at this graph, how can I identify if the solutions are real or non-real? Okay, real are the ones we've been doing for all of our mathematical careers. So starting in probably 6th or 7th grade, or even younger, you guys were graphing things that cross the x-axis. So as polynomials go, you know it just goes up and down almost like a roller coaster. So basically, every time the graph crosses the x-axis and you can see a cross, that is called a real solution or a real root or a real zero. So I just went up and down a bunch of times. 1, 2, 3, 4, 5, 6, 7, 8 real roots. Okay? If I want non-real roots, that means some roots that have complex parts, then it is going to keep going up and down. It's just not going to cross the x-axis. So I'm going to go right on this same graph. I'm going to use a different color. If I went up and down a bunch of times here, up, down, up, down, up, down, up, down, okay? I have roots to this equation. They're just not touching the x-axis. So every time I go up, that counts as 1, down is 2, up 3, down 4, up 5, down 6, up 7, down 8. This is 8 non-real solutions. Okay, so let's look at the problem in your book, not in your book, on their 8.2.3 practice worksheet. It was number 3, and I'm going a little bit out of order here, but this asked you to sketch a graph that has 5 real solutions. So you're literally just going to go up and down and you're going to cross 5 times. Okay, so 1, 2, 3, 4, 5, and you're done. Okay, as long as it crosses 5 times and it doesn't do any extra up and downs that aren't included in creating this graph, then that's showing 5 real solutions. For non-real, now remember, every single time you have a non-real solution, they have to come in pairs. There's no way possible to have just one non-real. There can be 0, 2, 4, 6, 8, 10, etc. You cannot have an odd number of non-real solutions. Okay? So, non-real, again, it's just going to have to be, if we think about a parabola that never touches the x-axis, that would be 2 non-real. But we need 4, so we have to keep going. Okay, it would be a W that never will touch the x-axis. Okay, again, down is 1, up is 2, down is 3, up is 4. That's where we're getting 4 non-real solutions. Okay. Part B on that worksheet for number 3 asked you to do 3 real and 2 non-real. And there's lots of ways that you can do this, but it's going to have to do an up-down or a down-up without crossing the x-axis. So I might just start with those to get them out of the way. So if I go down, up, that's 2 things that are not touching the x-axis, and then I have to do 3 that are real. So I'm going to turn around and go 1, 2, 3. Okay, there are lots of correct ways to do this as long as you have 3 that are real, 1, 2, 3, and then an extra. Okay, so when you finish this, this is kind of the finish. If I didn't have any non-real, I would just finish by going up, up, up. From this point, if I go down and up again, that's where my 2 non-real come in. Hopefully that helps you a little bit. Shoot me an email if you're still confused on that.